Welcome to Food and Nutrition Expert Channel for smart eating, teaching, healthy living, and expert nutrition tips because your food should fuel your best life. Today I'm going to talk about food science behind every cooking with scientific examples. Cooking isn't just about taste, it's about its beautiful dance of science and art. Have you ever wondered why bread rises, why onions make you cry, or why some meat turn tender, why others stay tough? Behind every dish is a story of chemical reactions and transformations that turn raw ingredients into something extraordinary. Let's start with heat. When you fry an egg, the heat causes the proteins to undergo a process called denaturation. The proteins, which are coiled like springs, unravel and then form new bonds, turning the egg whites from clear and runny to opaque and firm. This is why overcooking an egg can make it rubbery. The proteins bond too tightly, squeezing out water and leaving you with a dry texture. You see? Now think about baking. When you add yeast to dough, you are actually creating a live fermentation lab. You are actually creating a live fermentation lab. The yeast consumes sugar, producing carbon dioxide gas that gets trapped in the gluten structure of the dough. This process is called fermentation and is why your bread rises. The warmth of your kitchen speeds up the reaction because enzymes in the yeast are more active at higher temperatures, typically between 95 Fahrenheit. And speaking of bread, have you noticed the golden brown crust? That's the Maillard reaction, a complex chemical reaction between amino acids and reducing sugars is what gives roasted meat, baked bread, and toasted marshmallows their unique flavors and colors. This reaction begins at around 285 Fahrenheit and is the reason cooking with high heat develops rich, savory flavors. Let's move to boiling water. Ever wondered why adding salt to water makes pasta taste better and cooking faster? Salt raises the boiling point of water slightly, meaning the water gets hotter before it boils. This higher temperature cooks pasta more effectively. Plus, some salt gets absorbed into the pasta, enhancing its flavor from the inside out. Now take onions. Why do they? It's because cutting an onion ruptures its cells, releasing enzymes that react with sulfur-containing compounds, gas that irritates your eyes and causes tears. Interestingly, chilling an onions before cutting draws down this reaction, reducing the tears. When it comes to meat, science plays a big role in tenderness. Have you ever marinated meat with pineapple juice? Pineapple contains bromelain, an enzyme that breaks down protein, making tough cuts tender. Similarly, slow cooking soft meat like brisket allows collagen, a connective tissue, to break down into gelatin. This happens to temperatures around 160 degrees Fahrenheit over several hours, turning a chewy cut into a melt in your mouth experience. Even your choice of oil in cooking has scientific reasoning. Oils with a high smoke point, like avocado oil, can withstand higher temperatures before breaking down. If you use a low smoke point oil like butter at high heat, it burns, producing acrid flavors and potentially harmful compounds. Food pairing also has a scientific basis. Ever wonder why citrus pairs so well with fatty fish? It's because the acidity in lemon or lime cuts through the richness of the fat, balancing the flavors and making them more palatable. This is supported by the science of pH acidic ingredient balance, the natural oils in the fish, enhancing its flavor. So you see, cooking isn't just about following recipes. It's about understanding the science behind what is happening in your kitchen. When you know the why, you can take control of the how, creating meals that are not just delicious, but also a celebration of chemistry and biology, working together to nourish and delight you. So the next time you cook, remember, you are not just preparing a meal, you are conducting experiments, unlocking secrets, and turning science into an art that feeds both body and soul. Do you see that? Thank you for joining. I'm so happy to have you listen to this scientific method of cooking, why it's good and important for you. See you next time.